Hello and welcome to our video about electrochemistry. Yes, as the name suggests, we are going to take electricity and chemistry and merge it together. So, what is this topic about? This is the study of the conversion between chemical energy and electrical energy. So, we are going to be converting between electrical to chemical energy or vice versa. So, now let's look at it in this way. There are two sections to this topic. Section number 1 is where we're going to be looking at how we can use electricity to create a chemical reaction and the applications that come with that in mining, in jewelry, and other stuff that can be applied for this particular topic. So now, the other section is going to be looking at how can we have a chemical reaction occur such that it generates electricity for us. Yes, we're going to help ESCOM and load shedding as well as load reduction. But before we get into that, any topic that we do, we definitely need to make sure that the foundation is correct so that we can understand each other with the students or with yourselves. So now here's the idea. To understand electrochemistry, you first have to know what is electricity. And you also need to know what is a chemical reaction so that you can be able to understand how are these two related to each other, chemical reaction and the electricity. So please, before we continue, take a few moments, pause the video and think about the two questions. What is electricity and what is a chemical reaction? Then you can look at the third question of how are these two related? That way you will understand what we are going to do in this particular topic. Of course, we'll explain it in a moment.
A few moments later.
Okay, so now we're going to get the answers to the questions. Now, electricity is defined as, or simply defined as, the flow of charge. So charge has to be flowing. The movement of charge is referred to as electricity. But what is charge itself? Charge is electrons. So it's the number of electrons that you have. They have a specific charge. Combine the charges together, you will have the total charge that is flowing. So it is a matter of electrons. Then we have what is a chemical reaction. Now, a chemical reaction is the sharing or transfer of electrons between atoms or molecules that causes a change in their chemical properties or in their forms. So that's the one we are focused on. Of course, you can get some different chemical reaction definitions depending on the topic that you're currently doing, but more or less it's always centered around the transfer of electrons or the sharing of electrons as learned from the chemical bond types that we have. So we are more going to focus on, so we have three chemical bond types: metallic, covalent, as well as ionic. We are focusing more on the ionic because of the following situation, that the applications that we are doing in electrochemistry are centered around what we call redox reactions. So redox reactions are started in grade 10, dealt more in grade 11, but we are going to now look at the applications of those redox reactions. So what are they? These are special kinds of chemical reactions in which electron transfer takes place. So we are only concerned with the type of reactions where there is a transfer of electrons from one substance to another one. So there has to be that movement of electrons. Lo and behold, we are actually defining again electricity, movement of electron from one to another. So that's how the two are actually connected as per our third question. Now, let's just dive into the redox reaction. Redox reactions, the word redox comes from the combination of reduction and oxidation. So it's what we call reduction-oxidation reactions. So what is reduction? Reduction is when a compound gains electrons. So when an atom or molecule gains electrons, we call that reduction. We usually remember it as gain of electrons is reduction. Now, the reduction comes from the fact that as it gains electrons are negatively charged, therefore whatever charge it had will be reduced to more negative or less positive. Now, the other side we have oxidation. So oxidation is the loss of electrons. So the compound or atom which loses electrons is said to undergo oxidation. So that's what oxidation is. It is the loss of electrons equals oxidation. So as we can tell, this one then becomes more positively charged in this situation because it's losing negative electrons to the other compound, which is actually reduced. So that's what we have for our definition of redox reactions as well as electrochemistry and how the two, electricity and chemistry, merge together. So now we are going to go into the key concepts that we need to know so that we can go in to look at our two applications or two cells that we are going to deal with, one being electrolytic cell and the other being galvanic cell of voltage. Hi, so now we are going to take a look at the electrolytic cell as well as its components and functioning. So before we do that, let's define it. So the electrolytic cell is a cell that converts electrical energy to chemical energy. So in the components, definitely because we're going to be using electrical energy, we need a power source or battery. So without a battery, this cannot be done, or without a power source, this cannot be done. Then we are also going to need an electrolyte where our chemical reaction is going to be taking place. So what is an electrolyte? This is a solution or liquid that can conduct electricity through the movement of ions. So for ions to be moving, we need an ionic compound. So we will find that our electrolytes are going to be substances or molecules that consist of a metallic and a non-metallic part. That will be our electrolyte. Then we are going to need an electrode or electrodes. These are solid conductors that are used to connect the electrolyte to the external circuit. The external circuit being the wires and the battery or power source. So that is pretty much what we are going to be looking at. So let's look at the actual cell, which is right over here. So here we have an electrolytic cell diagram. This is the general diagram where we have the power source. So this one here would be our power source, which is a battery. Then we have our two electrodes. So for the electrolytic cell, we need two electrodes to be present. And then after that, this is our electrolyte. So this section here will be filled with the solution that can conduct electricity, which we've defined over there. Then looking at the battery itself, here's the key. This is the battery, therefore this side is the positive terminal, this side is the negative terminal. Which means that electrons from the battery itself are being fed out of the negative terminal. So when this cell is in operation, electrons are moving into this section here. So they are filling up all the way here. What does that do? This creates a negative charge around this particular electrode over here. So what has happened to the electrode? The electrode has been reduced. So whatever we were dealing with has gained electrons, as we had mentioned before. Therefore, it means that here reduction takes place. So we have reduction occurring at this particular electrode. Then what does that further mean? We have a special term for the electrode where reduction occurs, which is called the cathode. So here we have the cathode as where reduction takes place. Then on the other side, as the electrons are being fed here, they are not able to go back to the other side for the mere fact that there's no connection between the two, and the electrons here are going to be used up and turned into the reduction reaction that takes place. So we'll come back to that issue. Then, because the battery needs to get more electrons, it's going to be draining the electrons out of this particular electrode. So it's going to be pulling the electrons out of this section in order for the electrons to be fed to the other section. So that means that this particular electrode would be positively charged for the fact that it is losing electrons. So therefore, oxidation is taking place. So oxidation takes place on this side, and because oxidation is taking place, we call this the anode. So that's the electrode at which oxidation takes place. That's the special name given to that. So this is our functioning. So what we do, we take the power source, feed the electrons to one of the electrodes so that it becomes charged. Now that it's charged, it's going to be attracting what we call the cations. The cations are the positively charged ions. They are going to be attracted towards here. From where? From the electrolyte, because the electrolyte is made up of ions, which means that it has cations and anions. The anions, on the other hand, which is the negatively charged ions, they are going to be attracted to this direction here. So that's what the electrolytic cell functions like, and these are the components of the general electrolytic cell. The only remaining part now will be the different applications. So in our main applications, we are going to first look at what we call electroplating, which is where we take a metal and coat it with another metal, much stronger metal, much more expensive metal. For example, if you have an aluminium necklace, which is not worth quite a lot, you can coat it with some gold to make it more expensive or appear more expensive. So the expensive part of it, or the price tag, would be based on how much gold you coated with, because the more gold you use, the more expensive it is because of the price of gold. Or you can take a spoon, which is aluminium. Usually aluminium spoons are easy to break or bend. But if you coat them with silver, then they become much stronger, and it takes a long time for them to actually rust. So that's why we are going to be coating some metals with more stronger metals and more expensive metals. That's electroplating. The second part is going to be related with the mining industry in South Africa, which is copper mining. We know that Eskom uses a lot of copper for its wiring, and copper is used for various other things, but mainly for the electrical wiring, we use a lot of copper as a country. Therefore, the refinement of copper and the mining of copper is a huge industry, and one of the applications of electrolytic cells is in the refinement of copper, where we take the copper and we make it into pure copper, or copper ore, which is filled with impurities as a stone. Then we turn it into a copper that is pure and can be used for this electrical wiring. The other one will be the extraction of aluminium from bauxite, which is mined, and that will come in as an application. So we have three main applications of electrolytic cells that are required by the CAPS document for chemistry grade 12. Okay, now we are going to focus on electroplating, which is the application of electrolysis. Electrolysis is the conversion of electrical energy to chemical energy, as discussed before. Now, electroplating is a process of coating an object with a metallic substance to make it stronger or to protect it against rust, or what we call oxidation. Now, a relatively cheap and weaker metal like aluminium can be coated with gold or silver, which are much stronger because they do not oxidize easily, they do not rust easily. So when you coat an object with these ones, you are definitely going to have an object that lasts for much longer. Difficult to bend, difficult to break, and takes longer to actually rust. Now, it is very important to understand that in the electroplating cell that we are going to be using, we will need an ionic compound that is chosen specifically to help us, not to work against us. Therefore, we will want one that contains the very same metal that we are using to coat. For example, if we are coating with silver, we will generally use silver nitrate because we know that we will be able to get silver ions out of it such that it helps with the silver coating. Now we can take a look at the cell itself. So the cell will look like this. We will have our battery, which is the power source. Then the electrode on the anode side, on the positive terminal of the battery, will be connected. Then we will connect the metal that is weak and we are trying to coat on the cathode side so that we feed it with the electrons. Then as we feed the electrons, it will be negatively charged. Whereas this one, we will get the electrons out, so it will be producing positive ions into this solution of ours, and then the solution itself, the electrolyte, will also be producing positive ions. Now, what happens to all of these positive ions? These positive ions are then attracted to the spoon and they start coating the spoon. Because the spoon has the negativity, when the positive meets the negativity, it becomes zero so that it becomes metallic. So this will get coated all around with those silver ions that are in the solution, and then we have the silver around the aluminium spoon. So that is the process of electroplating. So the most important part, remember, sometimes they can swap around these things as long as the connection is to the positive terminal for the anode and negative terminal for the one we are trying to coat. So just take note, we connect it so that we drain out the electrons, then it gives us these cations or positive ions into the solution, and then they get attracted to the spoon itself that we are coating. The solution is ionic, so it will be broken up into its negative ions and positive ions. The negative ions will be attracted to this one because it's positively charged, but we don't care about that section. We care more about this section here, because actually here, when the anion meets the cation, they become the solution again, which gives us more of these ones in the solution to coat the silver spoon. So that is electroplating, the coating of a weak metal with a stronger metal in order to make it stronger or to protect. In this section, we are going to cover now copper refinement. So in the mining industry, when we mine copper, the rock that we find or the ore that we find is impure copper. So it's not pure copper, it's copper that contains impurities. These impurities are other metal forms that are not copper. So in order to refine that copper or make it pure copper that we can use for our electrical wires and other forms that we need the copper to be, we will use an electrolytic cell. Now, similar to the electroplating case, when we use this electrolytic cell, the electrolyte solution that is used will need to be a solution that contains copper so that it can help us in the coating instead of working against us or not helping us at all. Therefore, this is the diagram that is used, or this is a diagram that represents the copper refinement electrolytic cell. We use the copper ore and connect it to the anode or to the positive terminal of the battery. And then we need a pure copper rod that is used as a cathode. So that one gets connected to the negative terminal of the battery. As discussed when discussing the electrolytic cell itself, the battery then feeds electrons into this section of pure copper, which then creates a negative charge around the pure copper. So the pure copper is then negatively charged. So what does this mean? This means that whatever copper ions are present in the solution, coming both from the solution and from the copper that is degenerating. It's breaking apart because we are draining the electrons, leaving the ionic compounds which go into the solution itself. So these ones then get attracted to this copper that is negatively charged. Then the sulfate ions, on the other hand, let's do that. The sulfate ions, on the other hand, are then attracted towards the positivity and the positive copper ions. This just refines or refills our solution and just makes sure that the solution is still what we had before. Now, as the process continues, ions of copper will get to this side. When they get here, there are so many extra electrons that are fed from the battery that the copper that's here do not need. Therefore, they will get reduced. So what do we say? That's where we get what we call the half reaction of the reduction sign. So the copper ions meet two electrons and then they become copper solid. So as you see, when they are coming, they are in the solution. But when they meet the electrons here, they then become copper that is solid. Whereas on the other side, we have oxidation taking place. The half reaction for that is that this is containing solid copper, but the solid copper is drained of electrons such that it becomes a copper in solution as an ion. That's where the half reaction takes place, and that's the diagram or the equation for it. Now, as this process is continuing, we did mention that copper ore contains other metals. The metals that are extra do not get to be oxidized or to be reduced in this particular cell because of their relative oxidation potentials. Rather, they drop down to the bottom of the cell and form what we call the sludge. So the sludge is the collection of those impurities that builds up at the bottom of the cell. Now, they usually do ask us, what is the significance of the sludge? Now, that has to do with the metals that are contained in that copper ore. The metals that are contained usually consist of gold, silver, and platinum. Therefore, they are what we call precious metals, valuable metals that can be sold to make an extra profit. So, this mine is basically a copper mine. But while they are mining the copper, refining the copper, they find themselves with some extra gold, silver, platinum on the side to have a side hustle. Therefore, they have more profits in that particular business. So that's particularly the significance of that sludge. So that is it for the copper refinement. Just go through the components of the cell, understand how it functions, also understand the importance of the sludge that is formed and where it comes from, as well as the metals that it can contain. It's very important. Gold, silver, platinum, all of them very, very